Hello, dear students. This is your Professor Lazaro Pino, and today we are having lab number 1, measurements. A measurement refers to the comparison of an unknown quantity with a known quantity. The result of a measurement is a numeric value with certain units. We can measure, for example, the length, and then we can use a ruler. The ruler is in centimeter, then the answer will be in centimeter. Or we can measure the mass. For example, we can use a scale, and the scale is in grams. Then you will report the mass of any object in grams. Or you are going to measure the capacity of a liquid, and using a graduated cylinder, you will report it in milliliters, or the temperature using a thermometer that can be in Celsius degree. Let's go to the ruler. How can we use a ruler? The distance between every number that you can see here represents 1 centimeter. And you must start the measurement here at 0, not here. You can see that this sharpener, for example, is around 1 centimeter. Then you can say that the sharpener is 1 centimeter until this moment, because later I will show you something else about measurements. Well, between the 0 and number 1, or 1 centimeter, you have 10 lines. Every line represents 0.1 centimeter. In other words, it's 1 millimeter. So if we have here a block, you can be sure is that 0.4 is the length of this block. Oh, but it's something else more than 0.4. This edge is between 0.4 and 0.5. So you can estimate that is 0.45. Then 0.4 is certain, and 5 is the estimated digit. You will always estimate a digit in your measurements according with the precision of the instrument that you are using. But also you must say the unit. In this case is centimeter. 0.45 centimeters. Okay, here you have question number 1. You can stop the video at any time, and you can do the measurement and write it in your notebook. Later, at the end of this video, I am going to give you the way you are going to report your answers. If the ruler is in inches, you can observe that between 0 and 1 inch, you have a lot of different units. The bigger, the largest one is a half inch. But also you can see 1/4, 1/8, and 1/16. These are the different values of every line, or what every line represents. You can observe here better the value of every line. Now, I want you to stop the video at any time and report the answer for question number 2. What is the length of this object in inches? Remember to do the measurement according with this scale that you have here. Question number 5. Use a piece of paper, the regular paper that you have at home, to write a letter, for example, And I want you to measure the length and the width of of the paper, of the piece of paper, in centimeter and also in inches. Later, I want you to calculate the ratio of the length in centimeter divided by the length in inches. This ratio is very important because it's a number that you can use to do conversions between centimeters and inches in a measurement. Then stop the video at any time. You can do the measurement and report it in a piece of paper. Later, you will report everything at the end. A graduated cylinder is an instrument that can be used to measure the volume of the liquids. In this case, you can see that this graduated cylinder has numbers. Every number represents milliliters. 3 milliliters, 4 milliliters, 5 milliliters, and so on. Let's go between 7 and 8 milliliters. You can observe that in between you have 5 lines. Every line represents 1.2 milliliter. Then let's see how we can make a measurement. We can do a measurement. In this case, you have to go to the bottom of the liquid. Some liquids, the meniscus is this way, and some in this way. But you have to use always the bottom of the meniscus to do your measurement. For example, here you have a graduated cylinder, and this one is the number one. The volume between the volume that represents every line is 10 milliliters. And here you have 10, 20, 30, 40, 50 milliliters. So the lowest amount that you can measure using this graduated cylinder is 10 milliliters. But look at this. This one, every small line represents 2 milliliters. So the lowest amount that you can measure using this instrument is 2 milliliters. But in this one, in the third one, every line represents 1 milliliter. This is the accuracy of this instrument. Every instrument has a scale, and this scale, the smaller amount that you can measure using every one of these instruments is the precision of this instrument. For example, here you have a graduated cylinder, and you go to the meniscus. Let's see, let me use here. You go to the meniscus. You can see the meniscus, that is the lower part of the liquid, is at a number between 88 and 89. So you can be certain that the volume is 88 milliliters, but it's something else more. Then we can say that is 88.5 milliliters. Then this part is certain, and this digit is the estimated one. In every measurement, you have a certain part and an estimated part. Well, here you have question 4. Stop the video and do your measurement. Remember to report this in a piece of paper and later you will write everything in the last page. This is a precision scale, also known as analytical scale in a chemistry that is used in a chemistry lab. The reading of the weight is in grams and the precision of the measurement is 0.001 gram or 1 milligram. In this scale, you can measure in this scale you can measure until 100 grams, sometimes 400 grams or more. The precision also can change. It can be 0.01 grams, for example, or for example, 0.01 grams. 0.000 grams. Sorry. Let's continue. Well, if you're going to measure the volume of a solid, better you use a weighing dish and a scoopula. You can take the solid with the scoopula and you put it into the dishing plate, the weighing plate, sorry. So, but first, you must zero the instrument. You put the weighing dish, you zero your instrument, and then you begin adding your solid until you get the amount that you need. If it is a liquid, better you put a beaker, you zero the instrument, and then you put the amount of liquid that you want into the beaker, and you can measure the weight of this liquid. For the temperature, we usually have in the lab alcohol thermometers. Here you can observe one of them. In this case, you can see that this thermometer is in Fahrenheit units. The level is between 60 and 70. Here you have 5 lines. Every line in this case represents 2 Fahrenheit degrees. So the level here is between 68 and 70. So I will estimate that the temperature is 69 Fahrenheit degrees. Okay, this is question number 6. Here you have 4 thermometers and I want you to stop the video and calculate the temperature in each one. At the end, you will write everything in a page that is the one that you're going to report. Well, we have different systems of measurement. In this case, we have the metric system that the length is in these units, and also the weight and the capacity. But also in the United States, we have the English system that uses different units for length, weight, and capacity. We can see that 10 millimeter is equal to 1 centimeter, that 100 centimeter is 1 meter, and so on. Here you have also conversions between yards and feet, inches and centimeter, and of different conversion of mass. If you go to any any book of chemistry, especially the one that you're going to use, you can find different conversions that that can be used in calculation. Well, what are the rules for significant figures? First of all, what is a significant figure? Let's go back. For example, in this case, we said that the the answer was 88.5 milliliters. As these three numbers are different from zero, we say that we have one, two, three significant figures. Let's see how can you estimate the number of significant figures in a measurement. Let's go back and let's continue with the rules. Well, you can say that all non-zero digits in a measurement are significant. For example, in this number 211.8, you have four numbers and all of them are different from zero, so you have four significant figures. In this number, the number 2, you can see that you have 1, 2, 3 three zeros between two digits different from zero. In this case, you consider all these zeros significant. So this number has 1, 2, 3, 4, 5 significant figures. But if the zeros are to the left of the first number different from zero, these zeros are non-significant. Then this number, for example, has only 1, 2 significant figures. Trailing zeros for a whole number that ends in a decimal point, you can say that the zeros are significant. For example, in 320, you have 1, 2, 3 significant figures. But what happens if the number has no decimal point? Well, in this case, as you can see here, this number has only 1, 2, because this zero is not considered significant figure since you don't have decimal point. Trailing zeros to the right of the decimal place are also considered significant. So in this number, you have 5 significant figures. You can stop the video and study it very careful because you will need to apply this during all this class from the beginning to the end. If you report a number with a number of significant figures that is not correct, you will lose points, even though it's the number that you can calculate using a calculator. For any number written in scientific notation, you have something like this. A is a value that is considered exact, and the power that is represented by this part of the scientific notation number is not considered significant. So in this number 4,500, you can write in different ways. Which one is the correct one? The correct one is this. Why? Because this number has only 2 significant figures. You don't consider this part significant. So this one is incorrect and this one is incorrect. Since this number has only 2 significant figures, you have to report this this way with two significant figures using scientific notation. When a value is rounded, let's see how can we round a number. Look at this. We have a number, and we have to round it to the 10th. This number is, I'm going to write it here, 33.742. If you are asked to round until the 10, you will skip these two numbers. If the first number you are going to skip is lower than 5, you report 33.7, like in this case. But what happens when the number that you have to skip is, for example, in this one, you have to round until the 100. Then you will skip the first number you will skip is higher than 5. Then you have to round up. And then you will report 2.88. These are the rules for rounding up. For rounding, sorry. Well, in this measurement, you are sure that you have that the length of this pencil is 6 centimeters, but it's something else. And then you will estimate and you can say, well, it is 6.7 centimeters. This number has how many significant figures? 1, 2. Here you have another example that you can use to study. For example, this number has 5 digits and all of them are different from 0. So this number has 5 significant figures. This one has 1, 2, 3, 4, 5, 6 digits, but this 0 is to the left and is not considered significant figure. In this one, all the numbers are different from 0, then it has 6 significant figures. These zeros to the left are not considered significant, so this number has only 2 significant figures. In this one, these zeros are not significant because are zeros to the left, but these zeros are after a decimal point and are considered significant. So this number has 4 significant figures. These zeros are in between 2 digits, different from 0. So you can consider these 2 zeros significant. In this case, it's the same thing. These 3 zeros are significant, but these 2 here are not significant since you don't have a decimal point. In a scientific notation, well, this part is not considered significant, so only these 3 numbers, so this number has 3 significant figures. Same thing here, since you have a decimal point, these zeros are significant and this number has 3 significant figures. Let me stop here. For example, if you have a number like this, and I want you to round until the 10, then you will say that this number will be 10.1, and it has 3 significant figures. It's very important that you take into account the rules of rounding up and significant figures in exercises like this. Okay, here you have from question 7 to question 13. I want you to stop the video, answer these questions, and then you will report the answers at the end as I will show you. In addition and subtraction, well, the best way is to make a line by the number with least digits. And you will report until here. Then you do your operation the way you are accustomed. But you will report until the 2. Your answer will be 77.2 centimeters. This is for subtraction 2. In the case of multiplying or dividing, well, you will consider in your answer only the number of significant figures in the number with least significant figures. In this case, you have here 3 and here 4. Then your answer must have 3 significant figures, as you can see here. This is for multiplication and also dividing. Well, stop the video and answer question 14, 15, 16, and 17, 18, and 19. Remember to report only in your answer the correct number of significant figures. How to do a conversion? Well, in order to do a conversion, usually you use what we call conversion factors. In this case, you're asked to go from inches to feet. And you know that 1 foot is 12 inches. This is a conversion factor. Well, what is given? The number given is 24 inches. Then you write here 24 inches. And after that, you multiply by the conversion factor. You plug it into here in such a way that you can cancel inches with inches, and you get the result in the unit that you're asked for. Then you multiply, you divide, and your answer in this case is 2.0 feet. You cannot answer 2 feet. Why? Because the given number has 2 significant figures, so your answer must have also 2 significant figures. If you report 2 feet, it is wrong because here you have only 1 significant figure and it's not according with the given number. Here you have a group of unit conversion that you can use in different conversions like this one that you will do. Stop the video and answer the questions from 20 to 26. Remember to report the correct number of significant figures in your answer. Maybe your number, your answer is correct, but if the number of significant figures is incorrect, you get a 0. You don't get any point for that. And this will be, there will be deductions in your answers if you don't report the number of the correct number of significant figures in all the lab from now to the end of this chemistry 1405. Well, you stop the video here, you answer these questions, and you will report in your lab this way. If you have more than one answer for question, for example, question 1, then you put answer 1, comma, answer 2, comma, and so on. If there is only one number in your answer, remember to put the units if, if it is necessary. Well, that's all for today, and I hope that you learn how to do measurements in a chemistry lab. That's all for today. See you in the next lab.